All right, so here we are on the Inertia7 site, where this is the source of all of our data science projects we've been working on. And now we're going to go over to my project, which I did on sentiment analysis of tweets of the presidential candidates for the 2016 election. So, like I said, classifying tweets by Hillary Clinton and Donald Trump as either positive, negative, or neutral. And the way we do this is a process called natural language processing, and this is a way to take the words that are in the tweets and you tokenize them, separate them into individual words, take out these stop words that have no meaning, and really just clean it up to make analysis a lot easier. The two algorithms I used for this project, naive Bayes and linear support vector machines, are both very common classification algorithms, and they were a great choice for this project, along with the natural language processing package in Python. And of course, this is a unfinished project, always trying to work on it, make it better. I would love if you're interested to replicate it, make your own contributions. The GitHub will be at the bottom, and a translation to R is in the works. Now, for this project, you're going to need basic knowledge of Python, statistics, economics. There's all these links we've provided for you here for Python, for learning all these things, and then here are the steps that I'm going to take you guys through right now. And I had some help from Mr. David Campos and Mr. Raul Alugio, so thank you. And Emil, thank you. So first off, we're going to load the appropriate modules into our Python environment. So these are essentially libraries in Python that make things a lot easier. Now, if you don't have the modules, you can use sudo pip install, other install commands in order to do this. But basically, some of the modules we have NLTK, big one, got to tokenize the stuff. We have scikit-learn, that's the main machine learning library in Python. We have time and matplotlib for the exploratory analysis, and just various other ones that helped me along with this project. So now, get the data. So you can't just go mess around and get tweets off of Twitter. You have to go in and make a Twitter development account. You need to make a whole bunch of, you just need to make an account really, and then it gives you a set of keys that you can use to access Twitter. So now we have provided a labeled data set with 400 tweets dating from those dates as you see above, and then we have some researcher labeled corpuses that I will train later. And the data was scraped through the process here, which I believe, yep, it's this link. So if you want to click right here, then it'll take you to there and you'll figure out how to scrape it. Now to clean the data. If you're not planning to scrape the data, you just want to use it, just go to the next section. So in order to do this, you need some sort of querying software, something to extract the data from the database file that gets outputted, and so SQL knowledge would probably be useful in this case. So those are the sections I chose out of the database file in order to do it, and I just chose the last one randomly, and I used it for the labeling. So now we're going to load in our data using CSV Reader through the code here, and this is a line of code I got from the internet to randomize it, because random is better. And the reason for that is because most mathematical theorems justifying these statistical procedures, they only apply to random samples. If it's not random, it doesn't really work. So now, exploratory analysis. So there's two types of learning, supervised and unsupervised, and normally unsupervised learning would be a critical step here. However, in order to do it, all of the features must be continuous and numerical, and this isn't the case. They're words, they're not numbers. I decided to instead analyze sentiment of tweets as a function of day of the week. So, for both candidates, as you can see with these nice little interactive graphs. We got 26 positive tweets on Monday, 42 neutral and 37 negative, and so on. As you can see, kind of good amount of fluctuation here. With Hillary Clinton, you got a lot of neutral tweets, makes a lot of sense. Now you get to Donald Trump. Ooh, okay, so you got negative, kind of goes away, and then boom, shoots right back up. Definitely one of the most polarizing one of the more polarizing presidential candidates, of course.
So what qualifies as a positive or negative tweet?
That's a good question. So I did classify this according to my own biases. The way I did it is usually in Twitter, if someone will say something positive and something negative in a tweet, like Donald Trump's gonna be like, "Oh, crooked Hillary Clinton does this, I do that." So negative, positive. So with those types of tweets, I just did it as neutral because my reasoning is that overall, because there's one positive and one negative thing, they kind of cancel. So that was my reasoning. I mean, obviously people are going to have their own different reasonings, and if anyone isn't satisfied with the labels, they are free to change them. But it did take a while. So from these graphs, we do notice a couple of things. So like I said, the negative fluctuates all over the place. Really not good, but unfortunately negativity does sell. And also another interesting thing, so I got an equal amount of tweets from Clinton and Trump, and Clinton spanned a shorter time, which means that Clinton actually tweeted more, which is surprising to me, honestly. I figured that Trump would just be shooting out tweets left and right, but you never know until you do the analysis. So, yeah. And, of course, neutral tweets, good tweets, better than negative ones, but it would be good for, these candidates to spread some more positivity instead of negativity. But now, let's go on to the model. So, I chose two models for these, naive Bayes and linear support vector machines. So the first one, the naive Bayes algorithm, it's a widely used algorithm for classification, and it all has to do with conditional probability, because that's all about Bayes. So as you can see here, which is a little small, we have the probability of one event given the other. So the probability of a tweet getting a certain label given the words in the tweet, it's equal to the probability that you get the words in the tweet given the label times the probability of getting the label divided by the probability of getting those words. So it's a little confusing, but he's proved it and it works, and it's so simple, in fact, that's why it's very effective, because it doesn't take a long time to train. You can just go down and do it. However, there are a few downsides to this. Number one, it's called naive because it assumes that all the features that explain the response variable, so the explanatory features, it assumes they're all independent. Now, this is a strong assumption because, well, that's usually never the case. In fact, it's very rare to find that. But that's just something it does, and that's one of the reasons it's so simple. And then another thing is that if you notice up here, so we have P of X, which is the probability of getting the words. So if the algorithm sees words it's never seen before, it's going to assign a probability of getting a certain label, any label, to 0, because it's never seen it before. And so that is where it can kind of be a little faulty. But since we're dealing with tweets, words, and everything, there's a lot of repetition, so don't really have to worry about that much. Next one is linear support vector machines. So this is a very unique classification algorithm. And so it's similar to clustering in a way. So like you have these points over here, and they're different labels based on something. And so what it does is it makes these decision planes that are functions. And so it makes these decision planes that are functions. And right here, as you can see, it's just linear, because that's all it needs, because this data is nice and separated and doesn't require a lot. However, that is never really the case in a lot of things. In fact, it's a lot more like this one right here, where there's a lot of overlap. And you can think of it in this example as words from different tweets going to different labels. So like, it's, let me see. You know, you can probably imagine tweets from, or words from different tweets going to different labels, and so that's where the overlap is. And so the great thing about linear support vector machines is that you can introduce mapping features, which can be nonlinear, and it allows it to literally just curve around points and instances in space. So now let's go and build the model. So here we read in the training and the testing data set, and we declare these different variables in here, and then we input it into our functions right over here. So this one is for, let's see, this one is probably for naive Bayes. Yep, because we're printing out the accuracy. And then this next one is for linear support vector machines. So if you've cloned the repo from GitHub, all you need to do is run these two functions or run make, and it'll run these for you. And the output is that it gets it right, I would say 60-something% of the time. It fluctuates depending on the randomness. And now let's go on to predict these unlabeled tweets. So here we're going to load in the unlabeled tweets, and then we're going to go and predict them. And it's already done for you here, so let's take a look at these. So here we have a couple. Okay, make America great again, positive. So this one is the weird one. You have people taking care, deserve a good wage, negative. That was the really big weird one that both algorithms actually classified as negative for whatever reason, probably due to my bias, but you know, that just happens. And you can see right here, it's missing words. It's missing to, it's missing the, you know. I removed those because they don't really help with the analysis. And then also, there are remains of hyperlinks, which is something I've been trying to remove as well. Work in progress, like I said. But other than that, you know, great, Iowa, positive, worst judgment, negative. Pretty good. Pretty good. So now linear support vector machine, once again, gets this negative label here for some reason. Let's see. You got crooked Hillary, negative. You got poverty, violence, negative. Yeah, so that I would say that's pretty good. Obviously not perfect, but the fact that we can train this on computers and have this work is pretty awesome. Now, in conclusion, you know, have we, you know, really taken another step in artificial intelligence and stuff? Yes and no. This has been done before. Like I said, there's things I want to do, remove hyperlinks, train on another more objective corpus that will allow for better accuracy. But nonetheless, this was a very eye-opening project. I do really recommend getting a Twitter development account, getting your own tweets based on handle, time, whatever, and do your own experiment. If you look into sentiment analysis on Google, you'll find crazy algorithms with very, very great accuracy, and it really just shows how much progress we've made with machine learning. And I really do want this to be a work in progress and not just a resume builder, so I will keep working on it, and if anyone else would like to clone it and help me with it, I would love some help, so thank you. Oh, shit. How did that